Hello and welcome to my demonstration of neural networks. I have been recently playing around with ANN, artificial neural networks, so I am just experimenting with this. I'm going to use bipolar sigmoid, that is positive and negative numbers, while the binary sigmoid is used for only positive numbers, 0 to 1. I'm going to create a vector of 4 by 6 columns, 4 rows. These are the input values, and if you check here below, I present the weights. So let's say I want to teach some patterns. I can tell that I want this row to have this pattern. That is on, off, on, off, on, off, like setting flags. But you don't have to use 0.5 or minus 0.5. You can use any number, -1 and +1. So with the output values, we tell that row number 1 should have an optimal value of 0.5. So when this pattern is pretty close, this value will get near 0.5 or equal to 0.5. I also want to teach the neural network that if this input value and this input value has a positive 0.5, then I want the second row to be 0.5, and for that I will have to turn this on. So let's train the network, and we can check out the error value, and now we can try this network. Let's see if the network can recognize this pattern, and that is, we put 0.5 here, here and here, and press recognize, and you see it's near 0.5. The rest of the values are -0.5 or -0.4. And we can check the second pattern. And you see it's 0.499. So it's pretty close. And the rest are -0.499. Now, the thing with neural network is that the numbers don't have to match exactly 0.5. You can have input data that are similar to this, and it will still recognize this pattern. So add 0.1 and 0.1 and recognize. And you can see you have still a positive value, and the rest are -0.499. So you can tell that it's this row. Okay, let's create a new neural network. I will skip adding learning data, that is the output value. That is, I will not set this to 0.5. Now we will take a look how this affects the coloring of the cells. Low values have a darker color, and high values, that is almost 1, will have bright colors. Now you can see that all cells in this column have similar color. And if you switch the input to the next column, like this, we can see what happens. So we told the network that if this column is triggered, then the optimal value is -0.5. And we did the same with this column, and the information is still there. It will not go back. So if you put this back, to 0.5 and we click train, nothing will happen, no change. We can change this back and we click train, so there is no change. Let's create a new network. We do the same as before. But now we tell that the optimal data for row number 1 will be positive 0.5. Now when I move the selection, first cell, what color it has, and I click train, and we move the selection. Now check the color. It's much brighter. Now one thing that is confusing, remember I told you that a low value has a darker color. So why has a value of 8.24 a darker color? Well, we can expand this column to see why. Let's create a new network. Neural network is amazing, but it is not magic. For example, let's say you have this pattern, and the pattern is 6 input neurons, but only 1 triggered. And we set the optimal value, click train, and let's recognize this. Looking fine. So let's say that the pattern is very similar, but it's only shifted 1. And we press recognize. So we should have a value near 0.5, but instead it's under 0. And this indicating that the second row has a better match. So shifting the pattern is not a good idea. Maybe you can say it's like categories. So column number 1 has a specific category, but now this category, there is no category. It's another category, so it can't get any reasonable data. So this is what I've learned with neural network. I'm using the aforge framework, and this little demo application is made in .NET. And this is the address of the aforge framework.